Hello, my name is Samson. I'm a lead product developer at Sake Innovations and Technologies. This is the latest of our product. It's called a Terrameter. Some people would know it as a resistivity meter, but what we have here is more than just a resistivity meter, as it does self-potential. We call it SP, resistivity, induced polarization, and electrical resistivity tomography. The system also comes with a mobile app that allows you to collect your data and collect your measurement on the mobile app from the comfort of your phone. The resistivity meter we have here is, as a matter of fact, a product we've carried for quite some time now, but this is our newest development, majorly because we just added about 3 other methods apart from just the resistivity that we've been doing for years. So as well as that, the new feature also carries a wireless communication system. We've got a mobile app for you on the mobile phone that allows you to pair your Terrameter with your mobile phone, so that as you are collecting your data in the field, the results are actually being sent over to your mobile phone. As well as that, we've added a solar power to this so that you don't ever run out of power when you are measuring in the field. Imagine a scenario where you want to walk in the field for days. You can simply just go with your solar panel so that you can keep your inbuilt battery topped up as you go. So what we have here, of course, is the Terrameter, and this is supposed to be an introductory video to this meter, because over time we're going to be releasing more videos that explains a number of features that we are offering in this product. And one of the reasons why we developed this is simply because we want Terrameter to be a product that is very accessible for geologists, for geophysicists, because you can imagine a typical electrical engineer, for example. Your cheapest tool is typically a multimeter. You probably can buy something like a multimeter for as cheap as say 2,000 naira in Nigeria today. But being a geophysicist, you typically have to cough out millions of naira in order to purchase one of these, and this has been the practice for years. So we are hoping we can have something that is very durable at an affordable cost. So I'm just going to use this video to show us some of the features of this meter. So when you are ready to take measurement, of course, the first thing you do is power up your meter. So it comes with a display screen, as well as connect to the mobile app you would have on the phone. If I want to measure SP, go to menu. So the first thing is saying I'm in resistivity. I can change it to IP, you can change it to ERT, you can change it back to SP resistivity. So if we're doing SP, we'll leave it as SP, then go. So send that. So there the measurements will commence. Now note, no electrode has been connected to my ABMN, so of course what we are going to be measuring here will not be a real life data, but we're coming back to that anyway. So the cycle of measurement has been set to 4, so the device is going to take 4 measurements and then average the result together. So there we are. Now that's SP. In the same manner, if you want to measure resistivity, I go back to the menu, so making sure now that the mode I change it to resistivity. So my measuring time is 10 seconds. My measurement current now, which will be used for resistivity, is 5 milliampere. So we're saying the system should inject 5 milliampere through the AB electrode into the heart and use that to estimate our resistivity. Now, a number of times when you probably just want to test your meter quickly, you are maybe not in the field. I don't want to start hammering electrode before I can ascertain that my meter is in good condition, which is the reason why we supply the meter with this test kit. So this test kit is essentially a model of the heart, in that we have a foil resistor system here, where the one at the middle is modeling the Mn terminal, the 2 at the extreme is modeling my AB terminal. So if I go on ahead and I connect these 4 cables on this test kit to the meter, of course when you purchase a Terrameter, you're going to be supplied with 2 of this test kit. One of them will be for high resistivity and one will be for low resistivity. So this one is modeling a 10 ohm Mn resistivity. So we can just slot the terminal in as AB Mn on it. So, and ask the meter to take the measurement based on the, now like I said, this network is modeling a 10 ohm resistivity. So if your meter is in good shape, I expect a result that is very, very close to 10 ohm when I'm done with this measurement. So we're just gonna go ahead and take our measurements now. Okay, so we are taking 4 measurements. So that's the first one happening. Okay, so you can see the first result saying 9.96, and just like I said, that's a 10 ohm model, so it should be very, very close to 10 ohm. Then as well as that, observe that the current the system is using for measurement is 5.38 milliampere based on what we set in our menu as a 5 milliampere. So it will take 4 measurements, estimate an error based on those 4 measurements, and tell us how accurate. What I mean, it's more or less like I give you a result of 10 ohm, I'm telling you what the level of confidence, the level of correctness I have in that error. So in that measurement. So now it's telling you I took 4 measurements. The first result is 9.96, the second is 9.96, the third is 9.96, the fourth is also the same. So with an error of just 0.03%. So you can see how tight this measurement has. So this is how you can take measurements of your memory, how you can actually test your meter indoor without necessarily going to the field using our test kit. Now this same thing I just did, like I said, it's something we can do from the mobile app without necessarily touching the Terrameter itself. Also we have the high P mode. So to measure high P, you go back to the menu and you change your mode now to high P. So scroll all the way to go, then sign go. Now high P, of course this is just a resistor I'm measuring, so I expect my high P to be very close to 0. So simply because a resistor does not have a chargeability. As a matter of fact, of course, let's see what my result will look like. Okay, so you can see that saying 178 millisecond, which is 0.178 ms, and that's because the chargeability of the heart, if you are probing in an environment where you have a very high chargeability, your chargeability tends to 1. So the maximum result you expect yourself to get from that chargeability is actually the 1. So a very high chargeability is telling you that the heart in there has some capacitive nature. Of course, once the data is collected in here, we have softwares that are meant to interpret the results. And one of the things we are currently working on our mobile app is also for you to be able to analyze your result right from the mobile app. So as you are collecting the data, the app is analyzing it for you in real time. So you don't necessarily have to collect data in the field, take it home, or bring it to a system to get your result. So that is high P mode. In the same way, we have ERT. Unfortunately, you will not be able to do ERT without an accessory, because ERT method typically requires a lot of electrodes. You can imagine about 64 electrodes for doing ERT profiling. So what happens with ERT is we have another device that is meant to do ERT. So the other device connects to the ABMN electrode here and expose that as a 64 or 32 or 16 electrode depending on your use case. So that we call it our switching, we call it the switching matrix. So the switching matrix enables the Terrameter itself to access up to 64 and 128 electrodes depending on your use case. Okay, so now we are going to repeat the same measurements from the mobile app to show us how to conduct our measurements without even touching the Terrameter itself. So in essence, on the app you start by selecting the mode of measurement you want to conduct up there. So if, for example, I want to do SP, I need to make sure I've selected SP right there. So let's start with SP. First, you make sure your device is connected and showing online here, and you do that by making sure your phone Wi-Fi is connected to the device. So once you've selected the right mode and your meter is connected, come down here and press the go button. When you press the go button, your device is going to make a beep sound to let you know I've commenced measurement. So if I go ahead and click on that, so my meter starts its measurement immediately. Of course, we are in SP mode and nothing is connected, just the test resistor anyway, so which will give us something very close to 0 volts in measurement. So you can stop the measurements by pressing the go button again on the app. So that ends the measurements. Now we go to resistivity mode now. So I select resistivity mode, so you can see in resistivity mode now there are 4 electrodes here. So the meter is telling you, I expect you to have connected electrodes on, 4 electrodes onto A, B, M and N terminal before taking measurements in resistivity mode. So we go ahead and just send. Now you see when we did SP, the result of our SP measurement is also sent back to the meter, to the mobile application. So which is why you see us having SP is equal to 7.8 up there. So you send you request for your measurement from the mobile app, you get results from the mobile app. As well as that, if you scroll to the bottom of the app, you can see here it has also recorded the measurement being made at the bottom here. So every time we make such measurements, we're going to be getting the logs of what was measured. So that measurement was made in SP mode. So this is the SP chart of what we measured. So the first measurement, the next one, of course all of them are close to 0. This is just a very small SP fluctuation. So you can see the maximum I have here is 25 microvolts. So now another SP just came in, so the graph will refresh. So every time we measure an SP, we chart it. You can also see the result in tabular form here, so telling you I have an SP of 7.8, 7.8. So with all this measurement being recorded for you on the phone, you can export it and save. And before you export and save, you can also annotate the data. Annotation is a process of me saying, oh, this measurement was made at the depth of this. So imagine this SP was measured at the depth of 1 meter. So I need to click on that edit button and annotate it by adding 1 here. So to tell us that, oh, this measurement was made at this depth. The same thing happens to the second one. I can say the measurement was made at a depth of 1.5 meter. So you can annotate all your data. At the end of all these, you can save the data, export it for future reference. As well as that, all this data you are exporting, if you turn on the GPS of your phone, the data will also be stamped with the GPS coordinates. And this is a good thing, because imagine a scenario where you've collected data from thousands of sites. I can come back tomorrow and I don't have an idea where I took what measurement. So by stamping each of these record with a GPS coordinate, you get to know where exactly did you collect this data from. Then as well as that, we stamp it with the time. We also added we are also adding a time stamp, so that you have an idea when the data was taken. So there's a question of when and there is a question of where. So we answered those by stamping the data before you export it. So this is for the SP. So I move over to resistivity. So now in resistivity mode, you need 4 electrodes. So you can select the number of cycles you want to collect. Let's say I just want 2 cycles. then how long of a time I want to do the measurement. The longer the time, the more accurate your data is. Well, it all boils down to how much time you want to spend on each site anyway, but the maximum time here is 60 seconds, which is still good enough if you ask me. So but for this demo, we're gonna just use 5-second measurement time. Then you also need to select the current. So this is the current you want the meter to inject for the resistivity measurement. You can select anything between 50 microampere and 500 milliampere. If you are in a very high resistivity environment, then you can select a low current as 500 microampere. But if you find yourself in an environment where the resistivity is very low, then you will need a high current in that scenario. So we are measuring just a 10 ohm resistivity, for example here. So I'm just going to use a 5 milliampere current in here. Then there are error checks here. While the measurement is happening, the Terrameter actually does a lot of tests. For example, I will check your battery first to make sure that the battery is not low before starting the measurement. I will test the MN probe, we test the AB probe, we test the HV, which is the high voltage generator we are using in the device. So there's a lot of tests we do so that we make sure that your result is actually good. But for whatever reason, maybe you are in a field, your battery is already running low and you still want to take your measurements anyway, you can disable some of this error so that the meter will not check them in order for you to finish your measurement. But once you disable an error, you really can't guarantee the accuracy of such data, because all these checks we do are meant to keep your data very accurate as much as possible. So we're going to keep all our error checks as whole, so to say, check for every possible error, and press the go button. So immediately the meter starts measurement. Now you see it's saying high current error. So this happens in any scenario where you might have chosen, if you chose a current that is not good enough for the resistivity being measured, so the meter will report such error. So this is one of the errors we're asking you not to disable, so that the meter can actually check while taking measurement for you. So I simply go back, switch that to 5 milliampere is good enough. So I go back to 5, I just switch this back to 5 milliampere. Then I'm saying take, let's say, 2 measurements and measurement time of 5 seconds, then go. So start measurement again. So that's step 1. So as the measurements have been taken, it's also been sent back to the app. So you can see I have my results saying I measured the resistivity of 10 ohms on the app. Of course, the resistor load we are using to test is a 10 ohm resistor. And while this measurement is done, if you see, you will see the table down here is also been updated. Let me expand that a bit so you can see this is the last measurement we just took. So telling you I measured. So this is where you can now come and annotate your data. So if this data has been recorded at an MN distance of 1, so set 1 there, and this has been recorded at an AB's distance of say 10 meters. So we annotate that data, then we can go ahead and take our next measurement. Let's say we moved our electrode, now we want to take a new measurement, so we send again. So the meter starts a new measurement, so it's going to take another 2 measurements at this depth and send the results over to the mobile phone. So measurement complete. So if you go down here, so you're gonna see we have another measurement here. So I just need to annotate this data as usual too. So all the data that you don't need, like all this one that resulted in error earlier that were being logged, these were logged when the meter was saying high current error. So these we don't need, so we don't need to annotate those ones. So these we annotate it. Let's say this is recorded at 1.5 meter of MN, and say this is at a distance of say 15 meters. So let's say the next one is at distance of 2, and say this is at AB distance of 20. So whatever the distance is, annotate your data and continue your measurement. So this is therefore the resistivity mode. The same thing happens in high P mode. If you want to do high P, so come to high P, switch to high P, set your parameter as usual. So you can see on the IP table we don't have any record yet. So we switch to induced polarization, also require 4 electrodes. Set all our parameters, say the loop is 2, the measurement time 5 seconds, and I'm using 5 milliampere with all errors enabled. So send. So measurement starts. So IP is a measure of chargeability of the heart, and it's one of the methods of geophysics. And a heart that has a very low chargeability will cause a C. So we denote the chargeability as C on the screen here, and the closer to 0 that value is, the less chargeable the heart is. So for a very environment that doesn't have too much chargeability, your IP will be close to 0. So you can see on the screen here, result is saying 41.9 millisecond, and that is 0.041 ms. So maximum IP you will ever see in any field measurement is 1. So the higher the value, the more we are saying that earth is chargeable, depending on what we have under the surface anyway. So the lower it goes, the closer it gets to 0, the less chargeable. The fourth one, the ERT method, requires it actually requires an add-on, and the add-on, we call it our switching matrix. So if you're going to do ERT with this Terrameter, you're definitely going to need another device apart from the Terrameter itself, and that's because in ERT method you are usually probing with a lot of electrodes. Imagine probing with as much as 64 electrodes. So with that method, you will not be able to use the limited 4 electrode that comes with the Terrameter itself. So what the switching matrix does is, it's another device that we connect to the ABMN electrode of the Terrameter itself and expose up to 64 or 32 electrodes depending on your requirements. So between 128, 64 or 32. So if you are doing ERT, you can always request for the switching matrix depending on how many electrode you will be using maximum. So we won't be able to show you that in this video. So in a future video that we're going to be releasing, we'll be showing you how to do ERT with this video. So one more thing I just want to quickly show us is that this device, like I said, comes with an inbuilt battery, and the inbuilt battery, of course, it's powerful enough to actually run up to 5 surveys, in fact 5 full surveys, let's say up to 5 days as a matter of fact. Now the thing is, this being an inbuilt battery, the battery is actually going to run out at some point anyway. So we've supplied you with a charger for it. So, and here is the charger. So the charging port is at the top of the device here. So simply plug in the charger, the system is going to start charging. So you can see it's telling me charging now. So the charger voltage is 15.7, the battery voltage is currently 12.2. so if you are looking at charging your device before you leave home for field work, of course you can charge with the electrical charger. But while in the field, if you run out of battery, yes, you can always trust the solar panel that is also supplied with the meter. So with the solar panel, it uses the same charging port as the charger. So if you plug that in and you expose your solar to sunlight, the system is going to be charging using the solar panel. So all this is what I have for you today as far as this Terrameter is concerned. I hope in a future video we'll be talking more about some other features that we have, because the wireless connectivity we just talked about here, there is actually another addition to that, because while we release the current firmware that your device is running, can actually be updated. So there is a filter feature that enables us to release a new firmware, share the firmware with you, so you can actually use that firmware to update your meter. So just imagine a situation whereby we release a new method. Maybe we had a new method to our list of methods in here. You don't have to bring your meter back to our company or send it back to us for you to add the new feature. All we do is share you a new firmware from the mobile app. You can actually, let me just quickly show us that. So if I come to this high button, so scroll to the bottom here, you can see a button that says firmware update. So I can load a firmware update. If I click on that, it's going to ask me to select the firmware that has been shared. So if we share you a firmware, you simply select that firmware and the mobile app is going to use that firmware to update your Terrameter. So this allows us to update features, bug fixes, improvements on your meter. So all this after sales service, we actually take it a bit serious because it's not a one-off thing. We keep developing, we keep making these things better. So, and every time we make it better, we want you to enjoy that feature at no extra cost. So we're going to meet in the next video. Thank you for watching.